Hello, good morning, y'all. Can you hear me? Yes, I'm going to assume yes. I'm very, very happy to follow Fred and Owen. And Fred, I'm assuming you're leaving for a temporary period of time, not for a long period of time. That's the only way I can deal with your particular job move. So I'm very happy to follow that. Hold on just 1 second. I'm actually teaching class right now as well, which you may be able to hear in the background. So this is a double Zoom for me this morning. When I wrote my abstract, I was really ambitious about the number of things I'd be able to cover in 10 minutes. And so my title is Restoration from Seed, What Are We Doing Well, and Is There Room for Improvement? So I'm going to talk about work that I'm doing at the University of Nevada, Reno in partnership with a whole bunch of people, Sarah Barget, Allison Onure, Owen Boffman, Rob Burton, and Mark Williams. And I'm going to give this first part, what are we doing well, a very short amount of time. And I'm going to talk more about where there's room for improvement. And in particular, this really exciting project, this science management partnership that I think is the way to go for increasing restoration success in the Great Basin. Okay, so if you had a chance to look at this presentation that the Society for Ecological Restoration did recently, there's a whole special edition of Restoration Ecology about their brand new international principles and standards for using native seeds in ecological restoration. This is a worldwide focus, and it's very cool. It's all open access, so I suggest you look it up. And here's a figure from this picture talking about all the important things that you need to do to get native seeds into restorations. There's a bunch of inputs, there's outputs, but along the way, you need to do a good job of collection, production, which I think we actually do really well here in the Great Basin for some species. You have to process and store them correctly. We do a great job of that too, actually. We have a lot of the Bend seed extractory, we have public and private storage. It's very important to test seed quality. We in the United States do an amazing job at this. Our seed testing and certification, weed-free seed, source ID labeling is really awesome. The place where I think that we could improve is with our inputs. We do a lot of work with seeds, but I think that if we get different seeds into this pipeline, we'll have greater success in the Great Basin. One thing, forbs need to be targeted for these efforts, which is a whole other set of talks. And then what I'm going to be talking about today is trying to get local grasses into this pipeline so that if we get the right things coming in, we can get the right outputs going out. I knew that Fred was going to show you those pictures of the source of the seeds that we are currently using in restoration. So I'm not going to use that slide, Fred, because you already did it. But what I am going to talk about is people do sometimes forget that there are a lot of examples of our current restoration practices not going well. So here's a very depressing case study looking at the Milford Flat Fire, which was Utah's largest fire in their history at that point. Very, very expensive restoration, but 5 years after the fire, the seeded perennial grass cover was very, very low, and it was not different from unseeded areas. Similarly, annual weeds were equal or higher in areas that had been seeded at great expense. And this is an unfortunate case study, but it's not the only example. There's some very large survey papers that have been written about restoration in the Great Basin, including this Arkell et al. Paper. This was a super extensive study of a bunch of plots and a bunch of different fires, looking at, again, these seeded and unseeded controls. And again, using the standard seeds that are available today, there were no differences in the cover of sagebrush, perennial grasses, or forbs between seeded and non-seeded plots. There was greater success with aerial seeding, possibly because those areas tend to be a little bit wetter or inaccessible, but drill seeding did not have the intended effect. More examples, Knudsen et al. I might not go over this one, but it is another very large paper, Oregon, Idaho, Nevada, and on average did not see improvements in native grasses or shrubs when they were seeded. And then finally, a paper that I cite all the time, this is from the Land Treatment Digital Library. This is looking at the proportion of treatments that were successful as determined by the BLM in different precip zones. So you can see less than 8 inches, 8 to 10, 10 to 12, 12 to 14. This is unsuccessful. This is partially successful. And so you can see the number, and this is absolutely successful. You can see that you get much more success in wetter areas, and we're still really struggling at the dry end. Not to depress you, but there's tons of examples like this. And here's one that I participated in myself in my lab. We planted a lot of these commercially available grasses in a really dry site. We watered them, we got them established. And then when we took the water off 2 years later, you can see this is the same tree. The plants could not make it in this site. They could not persist despite getting a really big head start. As Owen talked about, local adaptation is a really strong force in this area, so it's not necessarily surprising that in this restoration, the picture I just showed you, it's a very dry place, 5 inches, and all these commercially available collections and cultivars, this is their precip where they originated. So you can see they're very, very wet. Trailhead is about the driest origin of all of these things. So is it a huge surprise that when we plant it in this kind of habitat, they don't grow? Kind of not. That's what you would expect given what we know about local adaptation. That said, and here's where the magic comes in, we know that there's plants here. Look at these hills. This is not, right, a sandy blowing dune. Plants can grow in these super dry environments. And one of the key things we need to do is do more collecting of plants from this kind of place and increasing them to plant back into this place. So that is what I think we should improve on that arrow for our Great Basin seed industry, is really increase the availability of native seeds from these dry, disturbed populations, like the one you see in the background. My favorite thing here about this story is that it was really spurred by the Bureau of Land Management. We have, my lab have worked a lot with the Winnemucca district here. It burns a lot, they seed a lot. This is Rob Burton. He worked in that district for years. I met him when he was doing his master's work at UNR, and we just became friends and continued that when he went to work for the BLM. So Rob Burton and Mark Williams also used to be in the Winnemucca district. He's now in Utah. So Fred, you can work with Mark now. Really spearheaded this work. And as they've moved on, they've passed the reins to Andy Laka and JC McNally, who are our current partners in Winnemucca. And you can see they're very happy about what's going on. So these guys really did spearhead this effort of not accepting the status quo, not accepting the seeds that were available, but taking the initiative to actually make their own collections in their own district. So this is a form, if you're at all familiar with the Seeds of Success program, all seed collections have this form. This is just the top part of it. There's a lot of data. This was generated by the Winnemucca BLM office. They collected in collaboration with Ed Kleiner, NDF, a bunch of folks. They identified a population of bottlebrush squirreltail in Grass Valley. That's actually what that picture was I showed you. That was like a super tough looking population. They did an awesome collection. They went back on multiple days so that they got the full genetic profile of this population that's growing in a really dry area, about 8 inches per year. And here's a picture of the NDF crews out there collecting from this spot. So their goal is to collect from their own district so that they can then increase that and use that at home, right? What a revolutionary idea. And they were actually super successful. They did a ton of these collections, more than really they could afford to increase. So over 10 collections, including grasses and forbs and all these different things. So they came to me with this question, looking for my thoughts on which seeds should they increase first. And despite the fact that forbs are really important, I know that our farmers in the West know how to increase grasses. So my recommendation, and they of course agreed, that was their idea too, was to go with the POA and POA secunda, sandbird bluegrass, and squirreltail, Elamis elamoides, first, because we know how to grow them. And this is just more shots of this spot that the managers knew about, that is full of very tough plants that they wanted to collect seeds and increase. This is Grass Valley, Elamis elamoides, and this place, you can see there's evidence that this place is grazed. It has been burned multiple times. It's a droughty loam. It's about an 8-inch site. It's full of lots of weeds and disturbance, but you can see that cheatgrass is not getting a hold here. So that really cued these managers into being like, this is a population we want to collect and increase seeds from. Another one, button point Poa secunda. This is one of my favorites. Here's an up close of this guy. This is surrounded by cheatgrass, does not care. This whole landscape here is dominated by this Poa, and it's really keeping out cheatgrass. Again, burned, grazed multiple times, highly disturbed, 8-inch precip zone. This is a little more silty, but you can see that there are great populations in their district that they want to increase. So they wanted to know which of their many collections had the greatest potential of doing well in restoration. And so that's where my lab came in. We told them that we would be able to take all their different populations, screen them for these particular characteristics that we think are important in restoration, and then also screen their easily available commercial sources for those same characteristics. They can very easily order different types of Poa secunda, different types of squirrel tail, and use them in restorations. And really the question was, is there any evidence that taking the effort to increase their local collections would be worth it? So we narrowed in on 2 of their Poa collections, that Button Point I showed you, and another Winnemucca Mountain. Here's that Grass Valley spot, and then a Sonoma collection. These were all, for various reasons, their preferred sources. And then we compared their characteristics to these 2 Poa secundas. These are both from really dry areas, actually 6 to 8 inches, so drought adapted. The squirrel tails are a little more mesic, so more 11 to 12 inches. So we did an experiment to look at characteristics of all of these sources. And in my lab, this is the nerdy footnote down here. We've been spending a lot of time thinking about the characteristics that help seeds establish in the wild. What you're looking at here are scans of 2 Poa secunda plants. They're both 35 days old. So this one is really small and this one is really big. There's a lot of population differentiation here among them, among what they do. And I've starred here the characteristics that we looked at for these wild and commercial collections that we know are important. So when you come up as a seed, how big your seed is, how big you are overall, how many of these little root tips you make. These are areas where plants get resources from the soil, so those are important. How long are your roots? Well, your specific root length, which is about diameter, basically, how fine they are. And then how are you allocating energy above versus below ground? So we have a million experiments that have led us to think that these things are important in restoration. And the goal was to scan all of these collections for those traits. There's so much going on underground in the desert, you guys. It is very cool. This is a picture of scans that my student Allison Onure put together. She's gonna be talking later. This is Poa after 35 days. Sagebrush, look at that glorious root. And again, there's a scale bar here. This is Chenactis douglasii, dusty maidens, Origeron, and rabbit brush. There's all this stuff going on below ground that you would never know if you're just looking at the surface. But we grow them in super terrible soil, and then we let them emerge. And I think for the experiment I'm going to tell you about, we looked at them after 10 days of growth and then compared all these different characteristics. This is fun process. And I put, we just published this paper that has the methods that we used if you're interested in doing this for your own systems. It takes a lot of time, but it gets the best data. Okay, so the million-dollar question, when we compare our commercially available versus wild populations, which collections have the most promising traits for restoration? And first I'm going to show you the results for squirrel tail. So here we have the BLM's fantastic wild SOS collections. And then we have the commercially available things that are quite easy to buy. And then across the top, I have those different characters. So seed weight, when you come out of the ground, your root length, root mass ratio, number of root tips, etc. And I put a plus here in the column when that particular collection had the most favorable value of this trait. You can get all the real numbers in this paper. It was just really ugly, so I simplified it for you. But when you look across, you can see that this Sonoma collection of squirrel tail, it emerges the earliest. It emerges on average about 2 days earlier than all the other collections. It had about 99 root tips after 10 days, relative to about 70 down here. etc. Right? So it had the most favorable characteristics. So this is my recommendation for the squirrel tail. They're both awesome, but this one is the one I think probably has the most promise. Same for POA, and this was actually kind of surprising to me because remember I told you that these are also from drought adapted, or they're at least from dry areas. But when you look at these characteristics of traits that we think are likely to be adaptive, the wild collections really do stand out, and in particular this button point emerges earlier, has the longest roots, more allocation to roots, all kinds of root tips. This one looks awesome. The interesting thing about that is when you have plants that invest energy underground, they often don't make as many seeds. So this can be a little bit complicated for restoration. And so the next steps here are really to figure out how to increase these seeds so that managers have, you know, if you're in Winnemucca and you have a fire, you can get pounds and pounds of button point that you can use to restore your site. And so those really are the next steps. And again, Rob Burton, who spearheaded a lot of this work, he went ahead and got contracts with private growers. So this is BFI, and they put in fields of these locally collected plants for them. Here's this tag. This just warms my heart. This is 500 pounds of button point POA coming back to the BLM. There's a bunch of different seeds that are locally collected, increased offsite, and then came back. Again, as mentioned, it can be challenging to get these fields going. This is another collection, Panther Canyon. This is one of the first ones that the Winnemucca BLM put into production. You can see that first year, this is the number of pounds they produced, very, very low. But this is actually the Panther Canyon POA Secunda field up at BFI Natives, and you can tell that it's rocking it in year 2 and 3. So you can really start pulling lots of pounds off, even these smaller native plants, when they're grown in these conditions. They really can produce. So this is so cool. And again, so we have increased them. The next thing is to test how they're doing in restoration. And that's actually exactly the next talk that you're going to hear. So these are all the various collaborators on this work. And Sarah Kulpa is going to talk about our very first field trials that we're doing in the Winnemucca district, again with the BLM, putting in these locally collected farm increase seeds in experiments next to the sort of status quo mixes. And so I'd like to thank the Great Basin Native Plant Project for funding the screening work that I had just talked to you about. And then all of these lovely folks who helped us do that root washing and seedling data collection. And with that, I will stop sharing and take any questions.
So Beth, your results may really inform some of our subconscious or built-in biases that might assume that larger seed has better chance to survive. I know research is not complete, but could you envision a need for reorienting people's perspectives when it comes to these thoughts?
Yes, and that's really awesome, Patricia. I didn't even show the direction of these relationships, but you're right. When we considered plants that were most likely to be successful, we actually targeted the smaller plants and the ones with higher root allocations, not the bigger plants. And my feeling is when you look at the agricultural literature, there's lots of examples of drought tolerant dwarf varieties that people use in agriculture in areas where water is limited. And so the plant physiology world understands that small stature and drought tolerance go hand in hand, but somehow there's been a mix-up in this particular area of the world where we think bigger is better, even in drier places. And I think a lot of that has to do with confusion about forage production, pasture grasses. Obviously you want large ones. And if you have the ability to irrigate, having a big plant is fabulous. But there's just been sort of a mismatch between the collection and the production of the plants versus the thoughts about the drought adaptations that we actually need in the Great Basin. And Patricia, my goal is to just keep saying it over and over and over again and bringing data to the table so that we can really get this. And again, maybe showing pictures like I did of those wild spots in the Winnemucca district, where those are very small plants. They will not carry a fire, right? There's no fuel there. Showing pictures like that is maybe even more valuable than 10 years of us doing work. But yes, I agree with you. We really do need to think hard about our assumptions.